Hello, my name is Juan Garza. I've been in the pipe and design business for 36 years and would like to break down the spool pieces for ISO production, how this is normally broken down, and why we need shipping containers, flatbeds, and how this is transported on them on the 40 by 8 by 8 standard sizing for the spool pieces in the design, and how shipping size, like on the ISO itself, that you have to take into account. So let me do some sketches and some views for you to look at what you should take into consideration in your design.
Hello. How to design piping for shipping. Ever wonder what it takes to break up ISOs into spool pieces from a design point of view? Topics I want to cover are shipping containers, flatbeds, and then envelope sizes, the dimensions, the spools that we need to cut up to fit on for shipping. Take into account the piping OD, flange OD, pipe supports, valves and instruments, define the field welds, shipping sizes, constraints, installation order. Poorly planned field welds is really hurt your design and really hamper construction. So you want to take that in consideration. Here I'm showing a flatbed with spool pieces loaded up. How the fabricator or the shipper has it with blocks, and how they stack it and safely ship it from one place to the other. More likely from the fabrication shop to location at site, it probably won't be this orderly or as much shipping supports needed, but they'll just lay flat on the bed and then be shipped all day long to the unit or to the area. If they're shipping it through cargo ship overseas, or it's coming in overseas to your location, sometimes we go to fabricators offshore too. So this is just a picture, a rendering of the what would be in a shipping container and the sizes. Shipping container size is 40 by 8 by 8 feet. In some cases, it's for small bore pipe. Small bore pipe is 2.5 inch and below, and large bore pipe, which is what I'm talking about in this video, is going to be 3 inch and larger pipe that I'm talking about, that needs to be designed for a 40 by 8 by 8 container. Here I have an ISO that I've broken down into ISO view, overall view, and then I got a plan view. So let's start looking at the plan view. So let's break this ISO down into shipping spool pieces. This is a 12-inch carbon steel, 150 pound. We have 50 foot here that we need to take into consideration, and then you got 20, 40, the lengths go on and on. Let's go back to the ISO. So we got a flange here that we got to take a look at. Here's a dummy leg or a trunnion that's sticking out 4 feet that we got to look at also. And then here we have a vent that we need to take into consideration. So, and then we have in the ISO, I'm imagining it stopping at a tie-in point. So let's go back to the plan view and let's start at the flange. So in plan view, we have the flange. We have the OD of the flange. From the center line to the outer edge of the flange is 9.5 inches. So you need to take this into consideration in the design that you want to not look at. You don't want to look at just the dimensions that are on the ISO. Like this ISO here, it only says 50 feet, but you know that's not going to fit in the shipping container. So in order for it to fit in the shipping container, we'll break that down. So 9.5 inches to the outer edge, and then we need to locate a field weld because we already know 50 feet is too long. So we know that we've got this support here. It's 8 feet. Is it 8 feet? Yeah, it's 8 feet. So we know that that's 8 feet. So this support where it's going to be supported is 8 feet. Too thick. So then with that 8 feet support, then we know we can cut it back some more. So here we need to cut it back. We need to take off at least 10 feet. So that's past the 8 foot support, but we need to make the 40 feet from the edge of the flange to this field weld to keep it within 40. So then we'll need to take out 10 foot 9.5 inches to locate our field weld. So with that explanation, we've cut our first spool piece that'll fit. And then the vertical, the flange got a vertical of 1'2". So that won't work. So let's just make that 2 feet. Those numbers don't work. Because this elbow is 18 inches on a 12 inch. So I don't know, that number's not going to work. So let's cut that. Just for talking purposes, let's just make this 2 feet. Which still fits in our shipping envelope. But don't want somebody to say, hey, 1'2" is not going to be enough for a 12-inch elbow. So that should work out. And probably have another dot. But anyway. So the spool piece here is 40 foot long. So we've located our first spool piece. So we'll highlight that yellow, and we'll call it 001 spool piece. Let's break down the second spool piece. So if we're going to break that down, we need to go from the fill weld that we just located, this fill weld here. Let's go with that. And so we got 10 foot 9.5 to the center line of the elbow, which will cover it'll cover the support point of support. And then we'll have from the center line of this flange here, center line of this line, we have 20 feet to the center line of this elbow here going down. So with that distance, with 20 foot plus 10 foot 9.5 gives you 30 foot 9.5, but you got to take this 6 inches into consideration for half the OD of the pipe, for a 12-inch pipe, right? So then if you do all that, you get it from the edge of the pipe to that field weld, you got 31 foot 3.5 inches, which is well within the 40 foot length. So then I'll normally break down, okay, so we can add a little bit more here. If I know that this one is well beyond the 40 foot length, then I'll start working my way back from a point. So then I'll take some out of this 40, which I'll take 7'6", which to the edge of this piece of pipe will be 6 inches. So this will be 8 inches, right? 8 feet. So that'll end that spool piece in this, at least in this direction, this direction here. So we got 31 feet 3.5 inches, and then we have 8 foot in the up and down direction. But we have an elevation here, don't we? So we have an elevation there. Let's see, what was it? It was 6 foot, so we're still good. So it's 6 foot and then 6 inches for half the diameter of the pipe and half of the diameter of the pipe on the bottom. It gives us a 7 foot overall distance. So what are you talking about 7 foot? So let's pretend we got the edge of the pipe here, and the elbow goes down, and the edge of the pipe that goes here. In here, for this represents the center line, right? In here we have 6 inches, and in here we have 6 inches of pipe of half the OD. So this 6 inches, these two 6 inches plus the 6 foot gives us an outer dimension of this spool of 7 foot 0 inches, well within the 80 foot, right? So let's go back to the plan view. So then we got 7 foot here in the vertical, and we got our 31 3.5, which is within the 40, and then over here we have our 8 foot. So this fits in the box also. So let's color this spool piece. Let's highlight that. Let's see here. Oh, wrong color. Let's go to green. So this is our second spool piece here, vertical. Let's go to the ISO. And the ISO here, I got it at 7'6", but you got to add that little piece, like I just said, the half diameter of the pipe, so that'll make that 8 foot. So we've got our second spool piece here, here, here. So that's spool piece 3, 0, 0, 3. I guess we better do this one too. This is yellow, yellow. This is spool piece 1. Spool piece 0, 0, 1. Oh, I'm sorry, this is not 3, this is 2. Spool piece 2. And I like to keep them with the flow. So depending on your lead, but you want to keep it with the flow or the project or who you're working for. I like to keep them with the flow. That's what I tell the designers that I'm working with. So we'll keep the spool pieces with the flow. So let's go to spool piece 3. Spool piece 3 is a little tricky, but it's good for you to learn that you got to take this trunnion, this 4 foot trunnion. On the ISO, it'll just show a number or a dimension. Won't dimension on the ISO, but it'll call out the support. Nowadays, they normally just call out, it's the 5DS, for instance, for this talking purposes. And it's got 4 foot. 4 foot what? It sticks out 4 feet. It's something that you got to take into, experienced guys know this. Inexperienced guys, something they got to learn. So that's the 4 foot right there. So if we go to the plan view, we have 4 foot, and then we made this cut a few minutes ago at 8 foot. So that leaves our 41 minus to the center line minus the 8 foot plus the 6 inches gives you at 33 foot 5 here. And then with the 4 foot gives you a total length of 37 foot 5, which that creates our second one. But we have a vertical here too, don't we? So what was the vertical on the ISO? The vertical is 4 foot plus the outer, so that's adding a foot to that. So the overall there is 5 foot. So we have a vertical here of 5 foot, which fits within the shipping container. So in this one we have a shipping container, and then this is, I did the fill weld there because if you do an overall look, this is 6 foot plus the outer 6 inches, and then we also go up with the vent valve. So we'll need to take that in consideration, but let's finish this one here, and we'll highlight this one blue. And this dimension here is 18 inches. From the center line to the center line is 18 inches. So this spool piece is well within our 8 and by 40. So let's just break the rest of it down on the ISO. Since we got the parts pretty much broken up, I have the ISO here. So this was spool piece 3. Right? Yeah, I didn't number it down here either. So this is spool piece 002, spool piece 003. And let's go look at the 4th spool piece. Here you have the vent. So I've broken it down a 12 inch by 1.5 inch OLED with a 3 inch nipple. So I'm saying it's a total of 5 inches, and then the valve and the bowl plug, which I'm saying that's 4.5 inches. So in total, from the center line of the pipe to the edge of the bowl is 15.5 inches. So with those 15.5 inches, when you're breaking this spool piece out, it's 8 foot. So with adding the 15, you're already over the 8 foot distance. And this is 4'6". So then we'll take the 18 out, break this up a little bit to get it back within the 8 foot. So if I don't put this fill weld on, it will be oversized in 2 directions. We'll have almost 9 feet in the vertical here, which we don't want, and then we'll have 10 foot here. So we need to break that down and just break it out into 2 spool pieces. This is 4'6" by 8 foot 3.5. So this 8 foot 3.5 is going to have to be considered as the longest piece, which is over 8 feet. So it'll be in the 40 foot direction to fit in the container, which will be from here. All this will be over the shipping length. But let's get back to finishing this out. So we added the 15.5 inches, and we worked it out to where we got to take the 18 inches off to locate this fill weld, and that'll give us a spool piece of 8 3.5 foot, 8 foot 3.5 inches. So that'll be a second, third, fourth spool piece. So this will be 004. Let's color that one yellow. Nope. Let's color that one yellow. Okay. So then we come up with our last spool piece, which is 10 foot by 18 inches. 18 inches is the elbow for a 12-inch elbow, for a 12-inch line. So then that'll be there. So this will be our fifth spool piece. Sometimes you got to break them down to small pieces, but as long as they fit in two directions, you should be all right. This is our last piece here. Let's color that one red. From there to there. And that'll bring us to our tie point. And that is how I typically take a look at it. Take a look at the spool pieces. One thing to add, you can see we have 5 spool pieces. And with these 5 spool pieces, 1, 2, this one's spool piece 0, 3, 4, and 5. So typically on the spool piece number, it'll be the ISO sheet number. So in this example, it's the fluid code, the unit, the line number, the sheet number of the ISO, and then this will be where the spool piece number comes in most cases. Most companies do it that way. Maybe it'll be a whole gyration of numbers, dashes, no dashes, but this is the spool number. And this will help construction locate the unit, the line, and then this will tell them what ISO it's on, and then this spool piece. And then your ISO will have each one identified in your material for the fabricator. So in design, we'll create this whole spool, this whole ISO. I would put all this on one ISO. That's why it's not that complicated with valves and everything in it. You could probably fit 5 spools. Maybe you need to break this down to a sheet here. This will be let me get a little bit neater than that. So this here will be, if you break it down by sheets, this would be sheet 01. This will be sheet 02. If that's the case, then your spool numbers will start over because they start over on the line on the sheet. Most people do it that way. Some people start from 1 to whatever, but typically on S3D, then if you do the sheet number here, sheet 2, then this will be your spool piece 001, and this will be your spool piece 002, and this will be your spool piece 003. Typically now in S3D, this is all broken up for you, but this is the thought process on how to design piping for shipping that you need to take into account. A lot of people nowadays just route pipe in the model, make it look pretty, but there's a thought process behind it, and I hope you get something out of this. Again, let's go down the list here. Maybe I covered everything. Shipping container. We showed you the flatbed. Envelope sizes, dimensioning, how to dimension it, sketch it out. Spools, they got to fit inside whatever the project decides needs to be the spool. So this needs to be asked early on by the designer. Typically after all the piping is routed in the model, it's normally turned over for ISO production. Once you go into ISO production, the sheet breaks and the spool pieces need to be identified. And like we just did, the identification is typically by doing something like this on your breakdown. A lot of people take the easy way out and just start putting field welds where they feel should be If you want to be a good designer, you need to take your outer flange dimension like we did here, and you got to take your outer pipe dimension. You got to take your support location. You got to take these into consideration. Junior designer, mid-level designer, senior designer, this has got to be looked at. Checkers are normally more experienced, and they go back, and you don't want your checker kicking it back for a spool piece change. Just keep in mind how you need to design. OD of the pipe, OD of the flange, supports, valves, vent valves, instrument valves, take that into consideration. Sometimes tolerance, sometimes the shipping fabricator, once the fabricator is done with it, he'll turn it over to shipping, and sometimes shipping has a little bit of tolerances, may add 3 feet to the 40 foot, or a few inches to the 8 foot. It's acceptable. Containers, I don't think it's acceptable, because it's set on what size that needs to be. Yeah, I don't think this on the shipping containers you can get away with getting a few inches over, but on a flatbed you may be able to get over with a few inches over. Always ask your piping engineer or project, or your purchaser. Purchaser normally is talking to the fabricator. Define the field wells, shipping sizes and constraints. Just talked about that. Installation order, talked about that. On-site adjustments. Sometimes the smaller the spool piece, they have on-site adjustments if spool pieces are misfabricated or not designed to the ISO or to the spool sheet that the fabricator did. Sometimes it's lost between the isometric and the spool piece spool sheets that the fabricator, sometimes dimensions are off on that. But anyway, they can make on-site adjustments. And please do not poorly plan your field wells by just going in there and getting a gut feel where the field well's got to be located. Have some thought behind it. If you like this, please subscribe. Try to create another video like this. If you got any questions, send me a message. But I hope y'all got something out of this. Thank you.
So always check with your piping lead or your piping engineer to verify the dimensions that are required for your specific project. You need this to do your design and to do your layout, especially for ISO production. This should be on your job notes somewhere. And also, if you have any questions or comments, let me know, and I will try to answer them as best I can. Thank you.